Hello teachers, and welcome back to section 3-2 where we're talking about addition of whole numbers. In part 2 of this video, I'd like to spend a little bit of time talking about addition and other bases. And the problem we have here is base 5. So we want to add 144 base 5 to 34 base 5. Now we want to be careful that we do not read that as 144 because it's not. That's a base 10 system. So this really just is 144 base 5 plus 34 base 5. If I remind you what base 5 means is the only digits you have available to you are 0, 1, 2, 3, 4. If you want to represent the number 5, which is really an abstract idea, something with 5 things, then you would have to say you have 1 5 and 0 1s. So it looks like the number 10, but it's not. It's a 1 0. Now sometimes when you're adding or doing other operations in a different base, it's helpful to build an addition table. And so let's take some time to do that. So what this is saying is we're adding 0 plus 0. Well, we know 0 plus 0 is 0. And what that really means is 0 units plus 0 units. This is base 5. 0 plus 1 really is 1, 0 plus 2 is 2, 0 plus 3 is 3, and 0 plus 4 is 4. Now, 0 through 4 are the only digits that we have in our base 5 system. So anything bigger than 4, we're going to have to write it differently. But let's keep going. 1 plus 0 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4. But now careful here, 1 plus 4 in a base 10 system is 5, but 1 plus 4 when you're in a base 5 means you have 1 5 and 0 1s. That looks like the number 10. It's not. It's 1 0, and what it represents again is 1 5 and 0 1s. Now 0 plus 2 is 2, 2 plus 1 is 3, 2 plus 2 is 4. Now careful here, 2 plus 3 is base 10 is a 5, which means it's a 1 5 and 0 1s. 2 plus 4 reminds us of the number 6, which means 6 things, but what that really means in base 5 is it's 1 unit of 1 5 and 1, messed that up, 2 units of 1 unit of 1. I keep trying to say that's 2, but it's 1. 2 plus 4, picture 6 things, which is 1 5 and 1 1. Okay? Keep going. 3 plus 0 is 3. 3 plus 1 is 4. 3 plus 2 is 5, which means 1 unit of 5 and 0 of 1s. 3 plus 3 is 6, which really means 1 unit of 5 and 1 1. 3 plus 4 is 7, which means 1 unit of 5 and 2 1s. 4 plus 0 is 4. 4 plus 1 is 5, which is 1 unit of 5 and 0 1s. 4 plus 2 is the number 6, which is 1 unit of 5 and 1 1. 4 plus 3 is the number 7, which is 1 unit of 5 and 2 1s. And 4 plus 4 is 8, which is 1 unit of 5 with 3 1s. So there's this table. Now, how are we going to do this? Now what you can do is add your 1 units. Okay, now when you add 4 plus 4, add 4 plus 4, that is not 8. That is 1 unit of 5 and 3 units of 1. Okay, so 1 5 and 3 1s. So that's how you write that. Now we're going to add what's in the 5s column. We can't call that the 10s, right? That's the 5s column. There's 4 plus 3. We imagine that's 7. But, and think about it as 40 plus 30. That makes it a little bit easier. Okay, you've handled the units column. So that's like 40 plus 30, which is really, right, it's bigger than 5, so that's 1 unit of 5 squared with 2 left over of the 5s column. Again, you can look over here, 4 plus 3. I got rid of our table, didn't I? hold on. Okay, so I have our table back now. And if you'll recall, we added our units. So 4 plus 4 units is 1 5 and 3 1s. And then we moved on to the next 40 plus 30 units. Think about that as 70, but what that really is one column of 5 squared and then 2 columns of 5 left over. Now what makes this 40 plus 30 a little easier is you have your addition table over here. You see 4 plus 3, I highlight it for you, is 12. So 40 plus 30 would be 120, right? It's not 12, it's 1 2. And so that would be 120. Now let's add our next column, but our next column is just the 1 right there. So that's going to be 100. Again, it's not really 100, it's really 100 base 5. Okay? Now what do you think we should do? Well, we can add down our units column, our 5s column, and our 5 squareds column to get 233 base 5. And then finally we can say the answer here, 144 base 5 plus 34 base 5 is 233 base 5. That's not the only way to do it, although I think that might be the easiest way to do these addition in bases other than 10. It takes practice, so just be patient with yourself. Finally, let's wrap up the video by talking about some mental mathematics and estimations for whole number operations. What is mental mathematics? It is the process of producing an answer to a computation without using computational aids. Maybe try to do it in your head. Computational estimation is the process of forming an approximate answer to a numerical problem. So mental mathematics is an exact answer. You're just trying to do the work in your head, whereas estimation is not an exact answer, but it should be relatively close to the exact answer. And that's also so you could do things in your head and check if your answers are reasonable. It's a nice way to just check and see if you have a calculator answer that's reasonable. Okay, one mental mathematics is adding from the left. And so you could say 70 plus 20, looking at the tens columns, is 90, and 6 plus 5 is 11, and 90 plus 11 is 101. That's just a nice way to add in your head. I bet that's something that you actually do to be practical, say when you're in the store. There's something else called breaking up and bridging. And so notice what they're doing here. They're taking the first addend, 76. Try and highlight here. 76, okay, and adding that to 20. We're leaving off the 5, which gives you 96, and that's pretty easy to go back and pick up the 5 and add to that. So it's like breaking up and bridging is what they call that. So interesting. Trading off is a good way to handle this. This is also probably something that you might do in your head. So when you're at the store, adding 76 and 25 is not necessarily an easy calculation, although the way I'd probably do it is say, okay, 75 and 25 is 100, so 76 and 25 must be 101. What they're doing here is they're taking the 76 and trying to get it to a nice whole 10 or 100, so they just added 4 to take it to 80. But then you can subtract from 4 and take that to 21. And that was a technique actually that we saw earlier for adding. Hold on, let's go back and look at that technique. You remember the opposite change algorithm that I went over in the previous video? It's the same idea. We added 1 to 189 and we subtracted 1 from the other addend to keep it balanced. But that's a good mental math technique. Now we did it twice here. We worked with the 1s and then we worked with the 10s. But that's really, to me, looks like the same type of technique. So we're back to the trading off situation. You can do that all you want to, but when you're adding, you have to add to that one add-in and subtract from the other add-in. And then compatible numbers. I'm pretty sure you've done this before as well. So if you look at this long string of addition, 130 plus 50 plus 70 plus 20 plus 50, the pattern is, hey, let's notice there's 100 in here. Look, there's a, you could take this 50 right here and add it to this 50. Hey, there's 100. Or I can take this 130 and add it to that 70. Hey, that's 200. Well, I've got 200 plus 100, and then I add that missing 20, and then boom, I've got my answer. So pairing up nice numbers, because remember, we have a commutative property of addition, so the order you add these numbers in, it doesn't matter. You should get the same result no matter which order, so you can pair up nice numbers to get the job done. Making complete numbers. Now, again, this reminds me a lot of the trading off situation before, but it is different because we're not adding and subtracting. Notice here, 76, but we know 75 plus 25 is 100. And then you take that 100 and add the one that we didn't add in before, and it makes it 101. Then you have front end with adjustment. Now how do you do front end with adjustment? So notice what they're doing is they're adding the numbers in the front. So we're looking at the front end instead of the units. So I'm adding 4, 5, and 2 to start with. Okay, we know 4 plus 5 plus 2 is 11. And then you add the place value to it because that was in the hundreds place. You have to add the 2 zeros. Okay, then we adjust the 22 and the 31, that's about 50, and the 74 is about 70, so that's 120. But then you have to, it says the adjusted estimate is 1100 plus 120 is 1220. But notice that we don't have an exact answer here. This really is an estimation. Okay, so we're on to estimation techniques. But we're looking at the front end, and then we're rounding, sort of rounding our ideas after that. Again, rounding, finding things that pair up nicely. This is about 40. Right here, that's about 40. That's about 60, so it's about 100. And then down here, that's about 20, that's about 30, which is 50, that's about 50, that's another 100, so about 200. So these techniques, you've been doing them for a long time. Just calling out exactly what you're doing is what we're doing here with this computational estimation. And again, what's the value of estimation? You're in a hurry. You're checking out of the grocery store. You want to see if your real calculation makes sense, so you just crunch the numbers very quickly in your head to make sure your real calculation makes sense. All these are good uses of estimation. Clustering, it's used when a group of numbers cluster around a common value. Notice all of these numbers look very close to 5,000. Right? 4,724, a little bit above 5,000, a little bit above, a little bit below, a little bit above. We've got 5 numbers. Okay? 1, 2, 3, 4, 5 times 5,000 is roughly 25,000. So if you have numbers that are really close together, roughly, you could say that would add to be close to 25,000. And then there's classic rounding. 7,262 rounds down to 7,000. You're just rounding to the thousandths place. Remember the rule for rounding. If you're rounding to the thousandths place, you look at the number directly. Again, I'm having pen issues. You look at the number directly to the right of the number you're rounding. So I'm checking out this 2. If that number is less than 5, you round down. So that's why we went to 7,000. On the next number, again, I'm looking at the thousandths place and looking directly to the right. That number is 5 or larger, so I round up to 4,000, and we know 7,000 minus 4,000 is 3,000. And then using a range. This is also a good idea. You could round down and you could round up, and you know your answer will be between these two numbers. So 7,262, if I round down, that would be 7,000. 3,000. Now I know that rounds up to 4,000, but we're looking for a range, so we're just going to round it down to 3,000, and that's the low estimate. But the highest the answer could ever be is, let's round up, right? 7,000 rounded up would be 8,000. And then 3,800 rounded up would be 4,000, which gives us 12,000. Now we absolutely know our answer has to lie between 10,000 and 12,000. And I bet you've used that skill before too. You just needed to know what it was between. So I hope that this section makes sense for you. Make sure you practice. When it asks you to use these estimation techniques, really use them in the homework. Make sure you understand what they're asking. Even though there are other ways to do the problems, try to do it like they ask you to do it so you know how to share these tricks with your students as well. I hope you have a wonderful day, and reach out if you're having any problems. Take care.